Hopefully this is the last time we have to dance without the wind. I got a new capacitor and the price of these things is going up. This was almost $12, which is ludicrous. It's the brand Apple parts, I don't know. It's a 3 microfarads capacitor, which is what we need here. It's kind of big, which might be a problem. So it might have to just kind of, well, I don't know what we're going to do here. It's not going to fit very well no matter how we do it. So that might be a problem. But, oh well. Not much we can do about that. Because this is the only one I could find within reason without doing extensive searching. I don't know why these capacitors are getting hard to find though. But anyways, the leads are already stripped. I guess we'll connect it, I guess we'll use some string tubing to connect it. I'm going to move that wire out of there so it's not so pinched anymore. And I have to get some tube out. Let's see here. It's a little big, but I think that's the smallest I have. Oh no, that's not true. I do have something smaller. Let's use the smaller one. I finally got one of these small gauge wire strippers as recommended by the letter H, and it is in fact a great tool as would be expected. Made in USA. So we'll go ahead and strip this back. It's very, very thin and delicate wire, and lost a bunch of the strands, so we're going to do it again. Appears to be maybe 22 or 24 gauge. It appears to be 24 gauge wire, which is very, very small, but I guess that is all you need if we're only talking a couple, 2 or 300, 2 or 300, 0.2 or 0.3 amps. I don't know what this is rated for, probably 0.5 or 0.6 maybe. I don't know, whatever. It's tired and I'm late. So let's get this hooked up here, and then we'll solder these joints together. Oh, we need the tubing first. This is actually a bit too small. Don't think I'm going to be able to use this. Okay. So we'll go back to what I had originally. Alright, that should do it. So now we're just going to fold this over like this because it's such a big piece of shrink tubing over a fairly small wire. And we'll go ahead and shrink this shrinking tubing, and then we'll test it out. I don't see any reason why this shouldn't fix it. And I suspect that this might end up being a fairly decent fan. This appears to come from the same OEM as Windmere, and at least in my opinion, Windmere made a pretty decent fan. This, I think we said this is from the very late 90s, so stuff was definitely starting to get cheap, but it wasn't anywhere near to the point where it is today. You know, some of the products were still remotely satisfactory, and I'm pretty sure that this is going to be one of those products. But we will find out in just a few minutes. And we'll also figure out how to mount this capacitor. That's going to be a bit of a challenge. So before we go any further, let's go ahead and turn it on, and just to make sure that it actually works, before we waste time trying to put it back together. It just doesn't work. It's stupid. This is sticking out much further than I would like it to. Let's see if we can jam that back in there. Alright, here we go. It works. Seemed like it needed a couple seconds to get up to speed for the initial time there. I don't know if that's because the bearings are stiff or what. Yeah, they are a little bit stiff. So this probably could fair be oiled before we really go ahead and run this. Alright, so let's strap the switch back down. And then once we know where the switch sits, we'll figure out where we can put the capacitor. So the old capacitor, I believe it hung here like this. And this one we can't do that with because it'll cover these holes here that the motor, oh, for heaven's sakes. The old capacitor hung here like this, which is not going to work with this one because the mounting tab is in the center, so it would end up hiding those holes where the switch housing attaches. So I'm not really sure what we're going to do here. This is going to be interesting. So let's start with get the switch in place. Is this not the screws that... No, it's not. It's been a couple days. I don't like to have things apart for several days because sometimes you forget details like which screws go where and so forth. So the motor housing, it really doesn't give us too much space to work with. If we just stick it like this, we'll have to figure out how to secure the wires and everything, but we were just to kind of jam it there like that. That'll allow us to close it up. No, so it can't go there. It's really not too many other places that it can go. It could potentially go, no, it can't go like that. I hate to mount it on top of the motor. Is that an option? Nope. This is not good. That's not safe to have it like that with the oscillation going. Nor will it fit anyways. I don't know what we're going to do here. This is really becoming quite the problem. There's no extra space in this motor housing, and this capacitor is significantly bigger. I don't know what to do here. Can I get away with that? Okay, that fits. So we gotta secure it up like that somehow. It blocks a little bit of air from the motor, but I don't think it's going to be an issue. We will have to let's see here. This is really tricky. I think like that is where it's going to have to sit. We don't want those wires to go near the gears, so maybe like this is what it will need to be. So it's not super intuitive considering that we're about to service it, but I think just a tie wrap around there might be the answer. For now, since I'm not going to be running it at all until I service it, I'm just going to let it hang there, and I'll put it back together just so that we can get an idea of how the thing operates. Where's the holes? Oh, does this not work? Just gonna cut it real close. I think it'll work. I think it'll fit. It is close though, it's very close. That's cool. That's something's wrong with the switch, or not the switch, the knob. Knob's not fitting on with any amount of tension. It just comes right off. I don't know. That doesn't make any sense because it was fine before and we didn't mess with the switch, so that's a little weird. I'll have to figure that out in the servicing video. Alright, we're going to have one spare part, it looks like, because this only takes 2 screws. Oh, that's right, because the capacitor. So that is a spare part, but it's not one that we're ever going to use again. Well, the bearings seem pretty free. A little bit, a little stiff, but free enough to test it at least. Okay, now for the first time we should be able to see this operating properly. Let's go ahead and plug this in. I'll grab the kilowatts meter. And I don't think that we had a power rating on this thing, so we don't know what it's supposed to draw. But I would say somewhere between 0.5 and 0.8 amps most likely. Well, it's already off to the races here. We only got 114 volts. It's pulling 0.3 amps, which is a reasonable expectation. I might shut that oscillation off because of the capacitor not being mounted. Now, we may not be getting a good accurate test because of how the bearings are a little bit stiff, but it is working. It seems a little bit slow, but the power draw is reasonable. 0.3 amps, 34 the watts, the power factor 0.97. It's a nice slow low. It's really not moving much here, so pretty badly out of balance. But at the end of the day, it is a cheap fan sold at Walmart, so we have to keep realistic expectations. Even though it's a gentle breeze, it is pushing the air pretty far, which is nice. I like the fans that operate that way. Okay, let's go to the medium. Wow, the clock on the blade is awful. It's like totally out. That would explain some of the balance issues. That's pretty much impossible to correct with a plastic blade. It's very quiet. It's still a very gentle breeze, but it's traveling clear across the room. No problem. Let's see if we get anything more impressive out of high. Oh, power draw 0.33, 35 amps, 39 watts, power factor 0.98. High. The high does not work. It's probably just a loose connection. Alright, well, I guess that was a partial repair. We're going to have to continue dancing in the wind one more time.